Okay, so this is half past paper week number 2. So this is the even numbers that go with the odd numbers of last week. And between last week and this week, you've now done a full past paper. So we've got all the Sparks codes here. If you have Sparks as your homework platform at school, if you don't worry, but that's all the topics that we're going to go through. And let's get started with question number 2. In a village, the number of houses and the number of flats are in the ratio 7:4. The number of flats and the number of bungalows are in the ratio 8:5. There are 50 bungalows in the village. How many houses are there in the village? So we see questions like this a lot where we have to combine two different ratios. I've got the number of houses to the number of flats in the ratio 7:4. And I've got the number of flats to the number of bungalows in the ratio 8:5. Now, both of these ratios are talking about flats, but at the minute, we can't combine this into a 3-part ratio because those flats are different numbers. But we could very easily make them the same number. So I'm looking for the first number that's in the 4 times table and the 8 times table, and that's just going to be 8. So let's make both of these values 8. And to do that, I'm going to multiply this ratio by 2. To keep it equivalent, if you multiply one side by 2, you also have to multiply the other by 2. So the ratio of houses to flats to bungalows in this village is 14 to 8 to 5. So we've combined that ratio. I now know that there are 50 bungalows. So this value is 50. So to keep this ratio equivalent, we've multiplied by 10 here. So we need to multiply by 10 on all of the values. There must be 80 flats and there must be 140 houses. So how many houses are in the village? 140. Great. Question number 4. A cycle race across America is 3,069.25 miles in length. Joan knows his average speed for his previous races is 15.12 miles per hour. For the next race across America, he will cycle 8 hours per day. Estimate, a really key term that we need to learn for the non-calculator paper, how many days Joan will take to complete the race. So when we're estimating, we don't have a calculator. We're not going to work this out exactly. We're just going to do a rough calculation in our head. And for that, we normally round to one significant figure. However, specifically for this question, they don't mind if you round this to 15 or 20. So I'd say normally we just round to 20. One significant figure is always a good idea. But I think because we're really close to 15, because we're going to be dividing into 3,000, it feels like a sensible choice. So we're going to change the race to be 3,000 roughly miles long. And we know that he can go 15 miles per hour, roughly. And he does that for 8 hours per day. So if I times that by 8, 15 times 8 is 120. So how many days is it going to take? Well, this is how far we're estimating he can go in one day. You might have got 160 for that if you'd used the 20, and that's absolutely fine. We're then going to divide 3,000 by that value, so 120. Now, when I do a division and I don't quite like the question, or it's got quite big numbers, I like to write it as a fraction, and then I just keep simplifying that fraction. So dividing them both by 10 is the same value as 300 over 12. I'm going to half that on the top and the bottom to keep it equivalent. 150 over 6. They're both in the 3 times table, so 50 over 2. And then I know that that is 25. So I'm going to estimate that it would take him 25 days to complete the race. We're then told that he trains for the race. The average speed he can cycle at now increases. Obviously, he's trained, so he's got faster. It's now 16.27 miles per hour. How does this affect your answer to part A? So obviously, if he's cycling quicker, he's going to do it in less days. So if he can go faster, it will take him less days. There we go. Question number 6. A pattern is made from 4 identical squares. Now, the fact that they're squares is really important for this question. The sides of the squares are parallel to the axes. Point A has coordinates 6, 7. Point B has coordinates 38, 36. And point C is marked on the diagram. What are the coordinates of point C? So the most important thing you can remember here is that with your coordinates, the first value is going across, and your second value, the y coordinate, is going up. So this here is 6, and this here is 38. That's from the x coordinate. I also know that this value here, we're 7 up, and up here this value is 36. That's how far up we are. Okay, so looking up, I've got this a little bit of an annoying overlap. So that's not very helpful. But if we look going across, we can see that these 4 squares are all sat side by side touching each other. So I'm going to look, how far is it to get from 6 to 38? That would have a width of 32. And there's 4 identical squares in that space. So that means that it's 8 across each one, because 32 divided by 4 is 8. So each square must be 8 wide. And if we know it's 8 wide, we also know that it's 8 tall, because it's a square. Now that's a little bit annoying in the middle there, because we don't know where on that 8 that coordinate C is falling. However, if you look coming down from above, we know it's going to be 8 down and another 8 down, and that is in fact in line with that coordinate. So what can we do? We can either come across for the x direction, we can come across 16 from here, or we can come back 16 from here. It doesn't matter. I'm just going to add 16 onto 6. So that x coordinate for C is going to be 22. 16 across from 6. But for coming down, for the y coordinate, I am going to need to come down 16 from here. I can't go up 16 from here because that would get me, that would be too high. So coming down 16 from 36 gets me 20. So well done if you got that. A really, really difficult question. Lots of marks available, 5 marks. So 22, 20 was your answer for that one. Question number 8. The perimeter of a right-angled triangle is 72. The lengths of its sides are in the ratio 3, 4, 5. So I always like to do a little sketch if I can, just helps me to visualise it. So I've got a right-angled triangle, and I know that the sides are in the ratio 3 to 4 to 5. Now with 3 to 4 to 5, I don't know which one the 3 and the 4 is. I can just put the 3 here and the 4 here. But this one has to be the 5. That has to be the longest side because it's the hypotenuse. So if we're sharing, we know that all the way around the outside, the perimeter is 72. So I'm going to share 72 in the ratio 3 to 4 to 5. So to do that, remember you've got 3 parts, 4 parts and 5 parts. So all together, I've got 12 parts. If I count up all those lines, I've got 12 parts. So I need to share that 72 equally over those 12 little lines. And 72 divided by 12 is 6. So I've got 6 centimetres on each of those little lines. That means the first side of this triangle is 18 centimetres. The second side of this triangle is 24 centimetres. And the third side, the longest side, the hypotenuse, is 30. So I'm just going to put 18 here, I'm going to put 24 here, and I'm going to put 30 here. Doesn't really matter which way around your 18 and your 24 are, but really important that that 30 is on the hypotenuse over from the right angle. Okay, perfect. We now have to work out the area. So that's why that 30 being there is important, because actually we don't need that value to work out the area. The area of a triangle is base times height divided by 2. So I'm going to do 18 times 24 divided by 2. So that's quite tricky to do, 18 times 24 without a method. But what you can do is cancel the 24 with the 2, or cancel the 18 with the 2, entirely up to you, and make that 12. And we could just do 18 times 12 instead. 10 lots of 18 is 180. 2 lots of 18 is 36. Adding that together, we get 216 centimetres squared. But if you did want to do 18 times 24, I'd really recommend the lattice method for that. So 2 boxes across, 2 boxes going down, 18 times 24. Split every box diagonally, like that, and make them a little bit longer on the end. 8 times 2 is 16. 8 times 4 is 32. 1 times 2 is 2. 1 times 4 is 4. And then you just add down each diagonal section. So in the first diagonal section, I've just got a 2. In the next diagonal section, I've got a 6, a 3 and a 4, which makes 13, carry the 1. 1 add 2 add 1 is 4. So I've got 432, but then we have to divide that by 2 because it's the area of a triangle, and that is 216. So whichever way you did it, 216 was your answer, centimetres squared. They already put the units on the answer line, which was great. Question number 10. The table gives some information about the heights of 80 girls. The least height is 133, the the greatest height is 170, the lower quartile is 145, upper quartile is 157, and the median is 151. Draw a box plot to represent this information. So luckily for us, they've given us everything that we need. A box plot looks a little bit like this, and this is your lowest height, or your lowest value, whatever it is, your lower quartile, your median, your upper quartile, and your greatest height. So we are just going to plot those values that they've given us. There's not very much more to this. So the least height is 133, and always double check the axis just to check we are going up in ones. There is 10 squares between 130 and 140. So 133, doesn't matter how big you make these lines, I'm just going to go roughly like that. Probably best to use a ruler and not follow my lead and just freehand it, but there we go. Lower quartile 145, so that's there. Upper quartile 157, so that's there. And then the median is 151, so that goes there. And then all you need to do is connect those three in the middle and then draw a line going out to the highest and out to the lowest value. And that's it. A couple of other things that are worth talking about is that this value here, so the difference between the upper quartile and the lower quartile, that's called the interquartile range. And obviously the range we know is the difference between the highest and the lowest value. So if you're ever asked about the data, you can talk about consistency by talking about those values. I don't know if we're asked about that on this. No, I don't think we are. Work out an estimate for the number of these girls with a height between 133 and 157. So it's worth remembering that the median is the middle value. So 50% of the girls were lower than the median. So 50% of the girls are there and 50% of the girls are represented there, have heights between those two values. But also the lower quartile, that's 25% of the way through the data. So I've got 25% of the girls having heights here, 25% here, 25% in this section, and 25% of them have heights in this section. So then if it says work out an estimate for the number of girls with a height between 133 and 157, I just need to look. Well, 133 was the smallest person. 157 was my upper quartile. So that represents 75% of the data. We're told that there are 80 girls. So that means 20 of them are here, 20 of them are here, 20 of them are here, and 20 of them are here. So 60 of the girls we're going to estimate are between the lowest value and the upper quartile. Question number 12. Prove that the square of an odd number is always one more than a multiple of 4. So what I often see on these questions is people just trying numbers, okay? It's never going to be that. You have to do it algebraically. You have to do it with algebra. So an even number is written as 2n because you're saying it's in the 2 times table. It's 2 times something. So if you ever want to write an even number, if you're proving something to do with even numbers, we would write 2n. Therefore, an odd number is either 1 bigger or 1 less than that. And I tend to go 1 bigger just because it's nicer to have a +1 than it is to have a -1. Okay, so an odd number can be written as 2n add 1. That's how we write any odd number. Prove that the square of an odd number, so the square of an odd number would be to square that number, is always one more than a multiple of 4. Okay, so let's see what we get when we do square that. So remember, if you're squaring a bracket, you're writing it out twice. So 2n add 1 squared is 2n add 1 times another 2n add 1. And that is 4n squared, add 2n, add 2n, add 1. So that becomes, put it up here, 4n squared add 4n add 1. And we're trying to show that this is always one more than a multiple of 4. So yeah, this bit's in the 4 times table, this bit's in the 4 times table, and this is your one more that they've asked you for. So I'm going to write that properly by taking 4 out as a factor, just to really prove my point. It's 4 lots of something, add an extra 1. Therefore, 1 more than a multiple of 4. And that's it. That topic is proof, if you wanted to know. Question number 14. Y is inversely proportional to d squared. When d is 10, y is 4. d is directly proportional to x squared. When x is 2, d is 24. And find a formula for y in terms of x. Give your answer in its simplest form. So this is a really tricky question, and if you haven't studied this topic before, maybe go and have a look at this first before I go through this. So y is inversely proportional to d squared. What that means is if it's directly proportional, as one gets bigger, the other one gets bigger. If it's inversely proportional, as one gets bigger, the other one gets smaller. And how we write that, we say y, this is the proportionality symbol. And then for directly proportional, we'd put d squared. But because it's inversely proportional, we put 1 over d squared. Now, I always think that proportionality symbol looks a little bit like a fish. So I'll often say to my classes, you can't solve equations with fish in them, so you need to change that fish to be an equals and a k. And that k is some number that connects the y's and the d squareds. Okay, so we're going to put y equals k over d squared. Now we're told that when d is 10, y is 4. So I'm going to substitute those numbers in. 4 equals k over 10 squared, which means that 4 equals k over 100. How can we work out what k is? Well, we can just multiply both sides by 100 to get it on its own. So 400 is k. And that means that we can now go back to here and say that y equals 400 over d squared. And we now have this formula that connects y and d and joins them up. So now if I said to you d was 5, you could put that in. If I said to you d was 7, you could put that in. You can work out what y is. We're now going to do the same thing for this part. D is directly proportional to x squared. So no fraction on this one because it's directly proportional, not inversely proportional. And then instead of that little proportionality symbol, or the fish as I like to call it, we change it for an equals and a k. You might go straight to this point, and that's absolutely fine. So now I'm going to put in the values they've given me. I know that 24 is d when x is 2. So 24 equals k times 2 squared. And so 24 equals k times 4. Dividing both sides by 4, we can work out what k is, and that is 6. So going back to this point, we now know that d equals 6x squared. So I've got two different formula. I'm going to put them in yellow just so that we remember that those are the most important bits we've got to so far. Perfect. So then it says find a formula for y in terms of x. Well, I have a formula for y over here, but it's in terms of d. And I have a formula for d, but it's in terms of x. So what I want to do is make this so that it is x's. And I can do that by using the fact that I know that d is 6x squared. So I'm going to write y equals 400 over, instead of writing d squared, I'm going to write 6x squared, because I know that d is the same as this. So I've changed the d to be 6x squared, but I do have to square it. So that's going to be 400 over, and I've got to square everything in that bracket. So 36x to the power of 4. And that is your final answer. We now have a formula for y in terms of x, but a very difficult question, but one that we see fairly often, so worth taking some time to make sure you know how to do that. Question number 16. There are only red, blue and purple counters in a bag. The ratio of the number of red to the number of blue is 3 to 17. Sam takes at random a counter from the bag. The probability it's purple is 0.2. Work out the probability of taking a red counter. Okay, so we've only got 3 colours to worry about here. Let's do a little table. I've got red, I've got blue, and I've got purple. And we know that the probability of selecting those has to add up to 1. Now, if the probability of purple is 0.2, then the probability of red or blue must be 0.8, because we know probability of taking one of those counters from either colour has to be 1. It has to be certain that we're going to take one of those colours. So I'm now going to look at this ratio, and the ratio of red to blue is 3 to 17. So 3 to 17 means we're going to take our 0.8 and divide it into 20 parts. So 0.8 divided by 20. Now, again, I say to you guys, if you get a tricky division and you don't know how to do it, write it as a fraction. I'm going to say that that would be easier if I was dividing it by 2. in which case it's 0.08 divided by 2, which is 0.04. I now just need to multiply that by 3 to get the probability of red, so that would be 0.12, and I need to multiply it by 17 to get the probability of blue, or you can just take 0.12 away from 0.8, so that's going to be 0.68. Perfect. Work out the probability that Sam takes a red counter, so our answer here is 0.12. Question number 18. Here is the graph of y equals sine x for minus 180 to positive 180. On the grid, sketch the graph of sine x take away 2. So this is transformations of functions. There's a few different things that happen, but for this question, if you have a graph and you add 1, for example, afterwards, that would go up 1. If you have any function and you take away 1, it would go down 1. Here, we've got the exact same graph, but then we're taking away 2 afterwards, and so this is going to move it down 2. So all I need to do is take each point and move it, translate it 2 lower. I'm just going to take the key points here. 2 lower would be there, 2 lower would be there, this point would be there, and this point would be there, and then just join that up with a nice smooth curve. I'm going to do my best to do that on here. There we go. And that is the graph of sine x minus 2. It's come down by 2. Perfect. Question number 20. N is an integer such that 3n add 2 is less than or equal to 14, and 6n over n squared add 5 is greater than 1. Find all the possible values of n. So we're looking at inequalities here. First, let's look at the linear one. This one here is a little bit easier, so let's solve that first. So 3n add 2 needs to be less than or equal to 14. We solve inequalities in the exact same way that we solve equations. What we do to one side, we do to the other. Now, some people like to change it to an equals sign, solve it and then put it back. I think that leads to a lot of people forgetting to put it back, so I just like to leave it as an inequality symbol. And I'm going to start by taking away 2 from both sides. So 3n is less than or equal to 12, and then I'm going to divide by 3. So n is less than or equal to 4. So that was the nice straightforward bit. That's the linear equation. We know that n has to be less than or equal to 4 to satisfy that inequality. Now let's look at the other one. 6n divided by n squared add 5 has to be greater than 1. And again, what we do to one side, we're going to do to the other. I'd like to get rid of this fraction, so I'm going to multiply both sides by n squared add 5. That gets me 6n is greater than n squared add 5. Now, having n squareds, n and a constant term, the n squared tells me it's a quadratic, but this is giving me all the indications that I need to make it have a 0 on one side to be able to solve it. So I'm going to make this side 0, and to do that, I'm going to take 6n away from that side. You could make either side 0, but you kind of want to make the term that's squared, you want to leave that as a positive term. So that's why I've gone that way. Minus 6n add 5. Remember, they're not like terms, so we've got 3 separate parts there. Okay, now to solve that, we're going to factorise. This is a non-calculator paper, so it's unlikely that we'd have to do the quadratic formula. We weren't told to round anything, so it's probably going to factorise. So n and n, remember you're timesing to make 5, so that's got to be 1 times 5, and we're adding to make minus 6, so minus 1 and minus 5. So I now know that this quadratic has roots at n equals 1 and n equals 5. And we want to know when is it less than 0, because this is on this side. We want to know when is it less than 0. And I'm going to draw this to really illustrate my point. N is 1 is here, and n is 5 is here. And a quadratic comes down, goes like that, and goes back up. That was drawn badly, sorry. Where is that quadratic less than 0? Well, here it equals 0 on that axis. So this part underneath, this is the part where the quadratic is less than 0. So I know that this inequality is solved when n is bigger than 1 and less than 5. As long as I'm looking at these values here, the quadratic is less than 0, it's negative. Okay, so now I've got n has to be less than or equal to 4 and n has to be bigger than 1 and less than 5. But I wouldn't bother writing all of that because this is limiting me at that top end. So what I'm going to end up having a final answer, I can't actually have 4.5 or 4.7 or anything like that because n can only be less than or equal to 4. So my final answer is that n is bigger than 1, but it needs to be less than or equal to 4 because of that solution as well. And that is your final answer. But a very tricky last question, as always. Always that's the grade 9 kind of question, that last one. 5 marks available there, but hoping that almost all of you could have had a go at that bit and got some marks. Never leave the last question blank. Always have a go at something because there's normally marks to gain. Okay, fabulous. Really well done. Hopefully you've enjoyed that, and I will see you next week.